For the final exam review quiz part 1, what we are asked to do is solve a logarithmic equation, and what we're going to be if there's more than one separate and common. So, okay. One approach to this is to get the logs on the same side, combine them, and then solve that way. That's going to be a little bit longer and involved. I'll show you that in a moment. Another way is with the graphing calculator, like we did in a previous video, previous solution. You can also always solve an equation by graphing one side as, say, y1 and graphing the other side as y2 and finding where they intersect. There's always a good way to go ahead and check things so that if you ever had some issue with your algebra, you would find it right away. So let's do this one. We're going to graph log base 5 x plus 6. So we go to the math. Again, if you don't have the log base key, you can still do this with the change of base formula. It's a little bit more involved and complicated, but you can do it. You've got to learn how to use the calculator you have. X plus 6. So the most up-to-date operating system. And then in y2, we're going to put the whole other side. So that's going to be minus log base, the math key, and then you go down to log base. Got that, log base 5, x plus 2. Get outside, and then we do a plus 1. So we just enter what we have. We're going to see these in the graph. We're going to graph it. You can always like to go to a zoom standard just to make sure everything's there. And you see the intersection right there. One's going up, one's coming down. There's only going to be one intersection. And when we solve it by hand, we'll see there might have been two, but we would have to exclude one of them. So to find the intersection graphically, we go second calc. And there is a tool called intersect, number 5. We're on the first curve. We hit enter. It asks, is this a second curve? And notice it's gone to the red one, the y2. We say, yes, that's it. And for the guess, we hit enter one more time. We've got an intersection when x is -1, y is 1. Now that is our solution. What is the solution? It's the x value that we're looking for. So x equals -1. Just put that in there. Graphically, that's the only solution. Now you might be thinking, oh, logarithms, we can't have negatives inside. Well, we can't have the end result be negative. If you put a negative in here, you get -1 plus 2. The end result is +1. So that actually ends up working. Now, I will go through solving this with properties of logarithms. But now that we know what the solution is, it's oftentimes helpful. So what I would do without a graphing calculator is we can add log base 5 of x plus 2 to both sides. We're going to get it to cancel out here, and over here we'll get log base 5 of x plus 2. Okay, so now we've got log base 5 x plus 6 plus log base 5 of x plus 2, all equal to 1. Using the properties of logarithms, this can become a single log with multiplication. X plus 6, x plus 2, all equals 1. We can now do the log dance, so making a logarithm into an exponential. Remember, for that one, the base is going to become the base, stay the base. The answer over here becomes the exponent on the base. It's 1. Try to fix a mistake, you make it worse. And then on the other side, we're going to have the input. Yes, we really should have a big parentheses, that this is all inside the single logarithm. And so now when we go to work things out, we FOIL, right? X times X, and then 6X in there. So we're going to get X squared plus 2X, 6X plus 12 equals 5. We have a quadratic. We'd like to get one side equal to 0, so we'll subtract 5 here, subtract 5 here, and then we'll also clean up, we'll add these like terms together. Oops. We end up with x squared. 2x plus 6x is going to give us 8x. 12 minus 6 gives us plus 6. That all equals 0. Okay. We could go ahead and solve it graphically, but that's again why I would have, if you've got it graphically, I would have used this method over here, graph it at the very beginning, get our answer correct. So the only reason I would go into this particular solution is because you don't have a graphing calculator, right? So what we have to do now is we have to factor that quadratic into, or use the quadratic formula if you'd like that method, but factoring is be better. So we have x times x. 6 can be 2 times 3, but then when you add 2 plus 3, you get, wait a minute, did I do something wrong here? 6 plus, that's 12. 2 plus 3, 2 plus 3, well, this doesn't factor very nicely, but it should get a factor of -1, or +1, and 6. What did I do wrong here? Okay, bring that over. We got 6 and 2. 6 plus 2 is 8. You do 1 and 6, you'll get 7 here in the middle. Doesn't look like it's going to factor. I hadn't prepared for this. 6 times 2 is 12 minus, oh, I see what I did. Okay. You probably saw it a long time ago. Why did I subtract 6? I'm supposed to subtract 5. I was looking over here, and okay, that's why it's not 6. We're subtracting 5 from both sides. Trying to do too many things at once, probably, right? 12 minus 5 is 7. That's looking much prettier because that now will factor, right? 7 is 1 times 7. And if you add 1 plus 7, you get the 8 that's in the middle. Okay, so this is all going to work now. So when you have two things that multiply that give you 0, one or the other is 0. So x plus 1 equals 0, or x plus 7 equals 0. Subtract 1 here. You get x equals -1, which is the answer that works. The answer we got over here, if you subtract 7 from both sides, you get x equals -7. And that one, if you check back in the original, -7 plus 6, that's going to be -1. -7 plus 2, that's going to be -5. It does not work in either of these logarithms. It gives us an undefined answer. And you see from the graph, 1, 2, 3, 4, 5, 6, 7, you see it's not even in the domain, right? So this, you get these errant, they've got a special name for it, but these errant answers when working by hand at times. So you have to know, wait a minute, that's not a solution that will work. It's not in the domain. That's why we have you ask all these questions about the domain. It's not in the domain, so it won't work. If you do the graphing part, Graphs will only show real valued answers, so you never end up having to deal with um, with an errant answer like this that doesn't really exist anyway because it's not in the domain because it won't show up. All right, that was it. Number 16.